Okay, 4, 5, and 6 is the Wilcoxon signed ranked test. And in this case, again, there is a critical table value for the Wilcoxon signed ranks test. You are going to want to bring that up and print that out. Again, I may have a 1-tailed test or a 2-tailed test, and they gave me some different values I can check. And so I want to make sure I have that table also. So make sure you log on, get that one printed out so that we can consult it as we work through these problems. I closed my Word document, so now I got to bring that back up here. So, day 24, if I go back to problem number 4 where I left off, it says, a random sample of male students at a local university was selected. Each student reported his height in inches, and his height was actually measured. The results were in the table below. So this is very similar to what the previous one looked like. He reported 74. His actual measured height was 72.4, a difference of 1.6. So at the 0.05 level of significance, can we conclude by using the Wilcoxon signed ranks test that there is a difference between the populations of reported and measured heights for male students at the university? Complete the table as we did before. So we are going to start off with, on this one, by doing our positives and our negatives like we had before. Here, positive, positive, exactly 0, positive, positive, negative, positive, 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 negative, positive. So in my table here, I've eliminated one of my things because it was exactly right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. N is going to be 14 when I use my table. Again, on this one, we want to conclude, is there a difference? So my null is going to be, is it equal to 0? My alternative one, is it not equal to 0? If it was exactly equal to 0, there would not be any difference. So, on these ones, what we're going to do, if I'm going to figure this out here, is, first thing I'm going to do, I'm just going to go ahead and look up my number from my table and find my critical value, because that way, when I have to erase it and put it back, it'll make it easier than doing that. So I'm going to go ahead, just clear this out, go over here to my table. We said that n was 14. We had figured out n was 14. We are doing a 0.5 level of significance. Since it's an equal and a not equal, it's a 2-tailed test. So 2-tailed test at a 0.05 levels of significance means my critical value is going to be 21. So I'm just going to go ahead and look that up first before I do all the rest of my work. Otherwise it erases. So 21 is my critical value. I'm going to close that, go back over to my paper. 21, that's the value we looked up. So on this one, what we're going to do is order all our numbers in order. However, we're going to pretend that they're all positive numbers instead of having both positive and negatives. So I want to rearrange this in order, and so I would have the smallest number here, not including the 0, is the 0 or 0.3. So I'm going to have 0.3, did that one, which was positive. I'm looking here, I have another 0.3 that was negative. I'm looking over here, I have another 0.3 that was negative. Let's see, my next number, 0.05. I have a 0.5 that was positive. I have another 0.5 that was positive. Don't have any more 0.5s. I can see the next number I have is 0.6. So I have 0.6, which is positive. I don't have any other 0.6s. 0.7, I have a 0.7, which is positive. No 0.8, so now I'm going to go to 0.9. 0.9 is positive. And Then I don't have any ones. I have my next number looks like a 1.2. So I have a 1.2 which is positive. I have a 1.3 which is positive. I have a 1.6 my next number. Yep. 1.6, 1.7. That's positive and that's positive. 1.8 and 1.9. Positive and positive. So I put my numbers for my differences all in order, ignoring the sign. We're just going to assume they're all positives there. So, and again, I leave off the zeros when I do that. What I want to do is average my numbers on here if they're all the same. So in this case, I have 3 of them here that were all 0.3. My ranking here, I didn't rank yet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We had 14 numbers. That was our value for n, was 14. So in this case, instead of saying this is 1, this is 2, this is 3, because they're all the same, I'm going to average them and give them all the same rank. 1 plus 2 plus 3 divided by 3 would give me 6 over 3, which is 2. So I'm going to give all of these a value of 2 instead of saying 1, 2, and 3. On these ones have a 4 and a 5. 4 plus 5 divided by 2 would give me 4.5. So on these ones, I'm going to both give them values of 4.5. Then I had all my numbers, the rest of them were different. So if I have any numbers that repeat, I'm going to take their ranks and average their ranks out and give them all the same ranking. So all my 0.3s are going to have a rank of 2. All of my 0.5s are going to have a rank of 4.5. And then I just keep going on my list. So in this case, I look at how many negatives and how many positives. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 positives. And only 1, 2 that were negative. Just like on the previous sign test, I always go with the lower value. I'm going to go with the lower value. I had 2 of them that were negative. My 2 that were negative were these 2 right here. The 0.3s, right? We had a negative 0.3 and a negative 0.3. In order to find the value of my test statistic, I'm going to add their 2 ranks together. Well, their 2 ranks for both of these were 2. So 2 plus 2 gives us 4. Now that I did all that work, I can make my decision. My decision basically is the same way we did before. If my test value is less than or equal to my critical value, I reject the null. If my test value is greater than my critical value, we accept the null. So in this case, my test value is 4. That's way less than 21. We're going to reject the null statement. Again, it erased, but my null statement was there a difference? So my null statement was, are they equal to 0? My alternative one is it's not equal to 0. We're going to reject this one. So this is my true statement. At the 0.5 level of significance, can we conclude there's a difference? They're not equal, so yes, there is a difference between the populations of reported and measured heights for my male students. So again, if we do accept the null, there is no difference. If we reject the null, then there is a difference, just like on our previous ones. So on the rank sign test, the key, putting my numbers in order, ignoring the sign on them when I put them in order, and then if I have some values that repeat, I have to average their ranking and give them all the same ranking. If they don't repeat, then they just keep their regular ranking and you can go from there. All right, so Number 5, same kind of thing here. The following table shows the monthly return rates for 2 mutual funds during 11 randomly chosen months. At the 0.2 level of significance, can we conclude by using the Wilcoxon signed ranks test that there is a difference between the populations of Fund A and for Fund B? Again, asking, is there a difference? So my null is that it's equal. My alternative one, it is not equal. So on my table again, I am looking here, and can we conclude that there's a difference? And so we're comparing it to 0. We're going to get rid of any zeros off our list, so I'm going to get rid of that 0 there. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers left in my list. So n is going to be equal to 10. Since I'm doing, is there a difference? At the 0.02 level of significance, we're doing the two-tailed test. And I'm just going to go ahead and look at the critical value first before I do all the sign stuff, because I have to erase everything when I go look at my critical value. So n is 10, 0.2 level of significance when there's a two-tailed test. And so if I bring up my table, there it comes. N is 10. There's my row for 10. I am using a 0.02 level of significance on a two-tailed test. So my critical value there says it's going to be 5. My critical value is 5. So going back to my problem, my critical value is 5. We said our null was equal, our alternative not equal. Now I'm going to figure out my signs. I have negative, positive, negative, 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 negative. Positive, we're not counting that one, and a negative. I've got 2 positives and 1, 2, 3, 4, 5, 6, 7, 8 negatives. We said on the rank test, we have to put them in order from smallest to largest, ignoring the signs on there. So if I do those, I've got my smallest number 1.2, 1.2, 1.2. Both of those are negative. My next number there, I'm going to have 1.8 and 1.9. 1.8 and 1.9. 1.8 was negative, 1.9 was positive. My next numbers there, cross them off as I go, so remember I use them, putting those in order. I'm going to have a 2.4 and a negative 2.4, so 2.4 and 2.4. One of those was positive and one of those was negative. Then I'm going to have on my thing a 3, just a plain 3, and then I have a 3.4, and then I have a 4.3, and a 4.9. I'm going to erase all my X's now that I have my numbers written down. And again, we're going to get rid of the 0. So now we're going to rank them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We had earlier said that when we looked up in our table, n was going to equal 10, right? We have 10 numbers on our list. If any numbers repeat, we have to average. So in this case, these two repeat. 1 plus 2 divided by 2 gives us 1.5. Each of these are going to have a value of 1.5 instead of giving 1 a 1 and 1 a 2. And then right here, our numbers repeat. So 5 plus 6 divided by 2 is 5.5. Each of those numbers would have a value of 5.5. The rest are all different, so we don't have to worry about averaging their values. When we do our signed rank test, we're going to use the one that has the lower number of positives or negatives. So in this case, we're going to use the 2 that were positive. So we had 2.4 and 1.9. The ranking of my 2.4 was this 5.5 that we averaged out. The ranking of my 1.9 was the 4, because we didn't have to average that. So for our test value, we're going to take the 4 plus the 5.5, which is 9.5. 9.5 would be the value of our test statistic. So we take the ranking of each of our numbers that were positive because that was the lower number of positives that we had. We had more negatives than positives. So the 2.4 had a rank of 5.5. The 1.9 has a rank of 4. If I add those together, 9.5 is my value of my test statistic. So now I compare those values. 9.5 is greater than 5. Since my test statistic is greater than my critical value, we are going to accept the null. That's my true statement. Accept the null is my decision. So if we're going to accept that they are equal, can we say there's a difference? No. That one was not true, that there was a difference. And one last one. The following table contains the first exam score and the second exam score for a random sample of 12 students in a large college class. So first score was 75, second one was 80, difference of 5, or negative 5 in this case. First one was 76.5, the second one was 84.5, difference of negative 8, and so forth. At the 0.5 level of significance, can we conclude by using the Wilcoxon sign rank test that there is a difference between the populations of the first and second exam scores for this class? So again, we're checking, does it equal 0 or does it not equal 0, which means there is a difference. If I look at my table, I do have one that's exactly equal to 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is going to be our value for n. Oh, why did it decide to quit writing on me? Close the ink. Let me see if it writes then. Nope, it's going to be difficult. N is going to equal 11. So on here, we are going to use a 0.05 level of significance. Again, because it's an equal and a not equal, we're using the two-tailed test. And so the first thing I'm going to do is go ahead and go over on my table and find what my critical value is going to be. This is going to be difficult because my computer decided not to work right, but we'll get her to go. In this case, we said n was equal to 11. I got to turn my pen back on here. If n is equal to 11, it doesn't want me to write. I'll fix the computer. All right, let's see if it writes now. If n is equal to 11, there we go. And I was using a 0.05 level of significance on a two-tailed test. My critical value going to be 11. So my critical value is 11. Again, I have to clear this out and go back to our Word document and then hope my pen tool wants to work. And so we said the critical value was 11. On our test statistic, again, we're going to get rid of the 0. Negative, 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 positive, negative, positive, negative, positive, negative, negative. We've got 1, 2, 3, 4, 5, 6, 7, 8 negatives and 1, 2, 3 positives, which was our 11 that equals our n value. So again, we want to put them in order, ignoring the sign on there. So our smallest value here is going to be 2.5. Our next value, we have a 3, and then we have a 4. If we keep going on there, we have a 4.5 and a 5.5. Whoops, that was supposed to say 5.5. I'm just going to scribble it out because my eraser's not going to work. 4.5 and 5.5. Oh, I skipped some numbers. I am going to have to erase, but that's not going to work. Let's see if I can get it to erase. There we go. Let's go back. Okay. I better just X them out as I go. We have a 2.5. Turning my pen back on, hopefully. We said we had a 3, a 4, and then we have 2 5s. A 5 and a 5. Oops. I got my 4.5 already down there. And then I have my 5.5. And then I have 1, 2, 3 8s. And I have a 9. I think I got them all written down. Whoops. Turn my eraser back on. Now that I have them all written down. And my pen back on. So in this case, if I got them all in order and I have all my numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I should have them all because n was equal to 11. I now have them order disregarding the sign, pretending they're all positives. So this one would have a rank of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. On the numbers that repeat, we have to average. So in this case, I have 2 5s. I'm going to take my 5 plus my 6 divided by 2 and give them each a rank of 5.5. On my 8s, I have 3 8s. So I'm going to take 8 plus 9 plus 10 and divide it by 3. 8 plus 9 plus 10 divided by 3 happens to give us a value of 9. So each of these is going to have a rank of 9. And each of these is going to have a rank of 5.5 instead. So now we are checking. The lower number between our positives and our negatives was 3. So I'm going to use the 3 positive numbers from my list. The 3 was positive, the 9 was positive, and the 4 was positive. I'm going to use the ranks of each of those numbers. So 3 had a rank of 2. 4 had a rank of 3. And 9 was on this list, had a rank of 9. So the value for my test statistic, the rank of the 3 was 2, the rank of the 4 was 3, the rank of the 9 was 9. I'm going to add 2 plus 3 plus 9. If I do... Oh, wait a minute. Ignore me. I used the wrong number here. Hopefully you were sitting there going, hey, that's not the right number. I was doing 8. All the 8s had a rank of 9. I wanted to do the 9. I should have used that number there. So going back to my test value. My 3 had a rank of 2, my 4 has a rank of 3, and my 9 has a rank of 11. I should have used an 11 there. I tried to use the 8 instead of the 9. So the 9 has a rank of 11. If I add all those together, 2 plus 3 plus 11, 5 plus 11 would be 16. So now that I have the value of my test statistic is 16 and my critical value is 11, we know that 16 is greater than 11. Since my test value is greater than my critical value, I am going to accept the null. Again, my null statement was that it's equal. My alternative one is not equal. This is my true statement. So, can we conclude there's a difference? No, we're saying that they're equal, that there is no difference. So, on the Wilcoxon signed rank test, you have to put all your numbers in order, ignoring the sign, rank them, and then average the rank if there is more than one value repeating. To find the test value then, we use the rank of each of the values of whichever is lower. So in this case, the 3 positive numbers. Then we can compare them just like we did before.